And now we need to do some steering assemblies. So we're going to have two different types of steering assemblies. We're going to have a non-independent, so steering, so that's going to be non-independent. And then the other one is going to be IND steering, which is going to be our independent steering. So let's start with our steering. And I know I'm not putting everything in the collection. We're going to do that later. So let's pick our steering, our non-independent steering. And what we want for that, let me move my cursor back to the center of this wheel, Shift S, cursor selected. I'm going to do another cube. I'm going to scale it down, then move it along the Y. I'm going to move my cursor there. And we want this to be a pretty flat thing. So let me scale it down like that. And scale it along the Z so it's a lot flatter. And then scale it along the X so it's more like that. And we're going to call this steering rack. So underscore steering rack. Okay. And it's going to be a rigid body. It's going to have a mass driver. So let me copy this mass driver to here, except we want it to be 10, right? So that's the only rigid body we need, but we need some constraints. We need a linear motor, and we need a ball joint. I'm going to do Shift D, move that there, and then Shift S, selection of cursor. And let me zoom in on that. All right, so our linear motor is in the right position, but let's move our ball joint to right there. And let's set up this. So our second object should be the steering rack. And the first object should be the steering rack for the ball joint. And we also want to parent both of the, or we want to parent we just want to parent the ball joint to the steering rack. So Control P. All right, now we need to set up our steering so it kind of works. So what we want is to make a little reference cone. So I'm going to do Shift A, mesh, and then cone. I'm going to scale it way down to about that size. We say R, Y, 90, negative 90. And then I'm going to move it along the x-axis way out here somewhere. Now I'm going to call this underscore steering ref. And it's not going to be a rigid body. It's only going to be a reference. And I'm going to parent this to the linear motor, Control P. This is basically going to help us determine how far the rack has moved relative to the steering motor. So let's set up our driver for the steering motor. So the max impulse, we just want that to be something pretty high. I'm going to put 10,000. And for the steering velocity, we're going to set up something more complicated. So let me add a driver, open it in the driver's editor, and let me drag this out and up. All right, so our equation is just going to be this. It's going to be steering ref distance minus rack to ref distance minus steering divided by 100 times steering walk. Close parentheses, and then times steering speed. So I know that's kind of long and confusing, but what it's trying to do is it's trying to determine how much the steering rack rigid body is moving, and it's trying to match that to what our steering input is going to be. So that's how that works. But we have a lot of different variables here. We have steering, ref, distance. So let's do that. Ref, dist. Let's add another variable. This is going to be rack to ref, dist. And we're going to have another one, which is going to be just steering. And we're going to have two more, steering lock. Actually, that should be steering distance. Steering lock's fine. Steering lock. And steering speed. Actually, I'm going to change this to steering distance. Alright, so let's set these up. So steering ref distance. Let's move this so we can see the whole assembly. Alright, so this is going to be the distance. It's going to be a distance. And it's going to be from our linear motor to this reference. The rack to ref distance is going to be from, it's also going to be a distance. And it's going to be from the steering rack rigid body to that reference. Our steering is going to be a single property. It's going to come from our subframe, and it's going to be steering. And pretty much the same thing. Oh, sorry, that should be 0_ steering. And the steering distance is going to be single property again from our subframe. And it's going to be steering distance. And last one is going to be our steering speed, which is going to be from our subframe 2. There we go. All right, so it should be working now, no errors. We should have that set up now. All right. Now we need to do our independent steering. So what we want to do is, we want to copy these objects because we can mostly use them. So I'm going to do Shift-D and then Y and copy it up here. But I'm going to move my ball joint out quite a bit along the x-axis. About right, or actually I need to copy it. So actually let me just scale this down some, and then I'm going to move this out about the same spot. I'm going to move this in about right there. I'm going to press Shift-D, X, move it out, and then I'm going to copy this rigid body. So I'm going to do Shift-D, X, put it in between those two ball joints, and then scale it down quite a bit, about right there, and try and center it. All right, so this rigid body is going to be our steering link. And this ball joint we need to set up so that it attaches from the steering rack to the steering link. And this ball joint needs to just attach not to the steering rack, but to the steering link, like that. And this ball joint needs to be parented to the steering rack. This ball joint needs to be parented to the steering link. And we probably don't want, I think I'm going to make this ×5 for the mass factor. And we need one more constraint. For independent steering, we need a steering or a slider. So I'm going to do Shift-D, move it over here, and then I'm going to Shift select the steering motor and do Shift-S, selection to active, and now I have my slider. And we need to hook it up, we need to parent it to the steering rack, and we need to attach it. So I'm going to attach it to the steering rack, the second item. And I think that should be it. Just a couple more things we need to do. For the shock assembly, we actually need to add a driver to the x-axis limits. So let's do that. So check this, and then add driver, and it's just going to be var, it's fine. And it's going to be a single property, and we're going to target the subframe, and we're going to do shock travel. I think that's what I called it. Yep, 0.1, okay. This one needs to be negative. And then we just need to copy it over here, but make this one positive. All right? Yep, that should be right. Actually, we need to give our preload motor also all right, we want our target velocity to be something like, actually, we need to add a driver to our preload. So let's do that. And it's going to be 10,000 if preload is greater than 0, else negative 10,000. So we could do it negative. And our variable is going to be preload. It's going to come from our subframe. And it's going to be a single property, and it's going to be called preload. Right? No errors, that's good. And our max impulse, let's add that driver. We'll just copy this driver actually. And let's edit it. And instead of this expression, we're just going to do absolute value of preload. And that's it. Okay, so that sets that up. Let me just check my notes, make sure I didn't forget anything else. Oh, we need to add a mass driver to our subframe. So I'm going to copy it from the wheel. And I'm going to paste it here. Instead of 20, I'm going to make it 100. All right, I think that's it. Let's just make sure, oops. Let me just make sure that I have everything parented right. So if I move the upright, it should move everything except for the wheel. It does. If I move this rigid body, it moves everything. If I move this rigid body, it moves the lower ball joint. If I move this rigid body, it moves everything else. If I move this steering rack rigid body, it moves those, or the ball joint, which is good. If I move this, it moves all that. That's good. I move this rigid body, it moves that ball joint. I move this rigid body, moves that. And okay. I think that all looks good. Hopefully I didn't forget anything, but we can fix it later.